Okay, continuing, as I've said, we have supercapacitor number 2 and supercapacitor number 1. Now, the principal operation, the concept of this FMSJR design scheme number 8 is that the output of the solar panel number 1 there and solar panel number 2 over there, which is rated 12 to 18 volts. Each is 12 to 18 volts DC output, 100 watts each, which are connected in parallel with one another. So we have total of 100 watts, 200 watts rating, 200 watts rating, and the output is routed here through the wiring here, the wire mold wiring, into the bypass switch number 1 and bypass switch number 2. Now the operation is that the output of each is bypass switch number 1, bypass switch number 2 is routed to its respective charge controller number 1 here and charge controller number 2. Right now you can see the remnant voltage of 12.9 volts DC of the supercapacitor number 2, which was the remnant energy since yesterday, last night, because overnight the charge of the supercapacitor diminishes. This leaks, the energy leaks overnight, because the difference with the battery is that the battery can retain longer the energy source which is just developed, whereas the supercapacitor diminishes the energy charge on the from the day 1 to the following day. So that's why we have to maintain the remnant energy by charging it or by maintaining overnight the voltage, which comes down to 7.4 volts, and immediately we have to recharge it by closing the bypass switch number 2 in the morning, the next morning, so that will recharge back again. So right now today is 2:30 p.m. in the afternoon, 19 July 2021, Monday is the date. So we have to continue with this operation of demonstration and observation of our FMSJR design scheme number 8. Okay, so now, as I've said, we have 12.9 volts remnant energy from the supercapacitor number 2 here, and also the same voltage is maybe 12.6 or 12.9 also here in the remnant energy of capacitor, supercapacitor number 1 here through this charge controller. Right now, the charge controller is showing a green lamp here on the battery, indicating there's a remnant energy to the charge capacitor number 1, and also enabled already the load port, which is represented by the red lamp, which means that it can accept loading through the load switch number 1 here and load switch number 2 here. Right now, these two switches are open and in open position. So right now, I have to continue by demonstrating the principal operation of this FMSJR design scheme number 8. So right now, the remnant voltage is 12.9 volts. Okay, by closing the load switch number 2, one can immediately the power flow, energy flow will come to the ATS here. This is our pivotal function, static transfer switch, STS, which is the load port here, DC source, emergency source, and the battery source here. Whenever there's the red lamp lights, meaning it is ready to accept load, and it will be enabled, depending that whenever there's a energy source from the supercapacitor number 2 or supercapacitor number 1, depending which energy source is switched first, and there's a priority. So there will be a hierarchy. Okay, if this one represents the first source, the other one will be the second source. Which is in standby. Okay, now we have to close the switch here so to demonstrate the operation. So right now, immediately there's a load here, there's a power now powering up by the charge controller number 2, the output of which is routed through to the symbol. You can see the symbol, the lamp there, the battery symbol charging. There's an arrow charging the lamp, which is represented by the symbol, and the output goes through automatic transfer switch, which is indicated by the red lamp here, LED. So immediately there's a load actually here. So you see the load is already energized. Now there's another load which is over there, that one LED lamp, but that is not yet operational because that is fed through the inverter. If we are going to use the inverter, this inverter, which is right now we are not using the inverter to produce DC voltage converted to the 230 volts AC voltage, 60 hertz pure sine wave. But that's not the case right now. The case right now is directly fed to the automatic transfer switch or static transfer switch, the output, which is directly fed to the LED incandescent lamp, 12 volts rated incandescent lamp, which now we have load operating. So now the remnant voltage is 11.5 volts coming down